Okay, great. So if you could see my screen, hopefully. Um, Great. Okay, so great job sharing your ideas. We have a lot of ideas for assessment three. And again, how I'm selecting ideas is basically on top of, the creative aspect of it. I'm also choosing based off the feasibility of the idea. If it's either too simple or too hard, I'm probably going to skip that. So what this means is I chosen four ideas that you can choose from. Again, how this works, everyone, right? Just a quick reminder. Okay, so you're going to visualize an emotion or condition. So everyone or a lot of you submitted a proposal for an emotion to visualize, and you also shared some mood boards, which is good. But I'm going to choose maybe around. I actually chose four ideas. And what this means is you're going to choose one of the four ideas there. Again, you're not visualizing all four. You just need to choose one that's appealing for you or feasible for you to do, and then expand on that. Okay, so as I mentioned, everyone proposed. I choose the top, and then you choose one idea to visualize. Okay, so here are our ideas. So great job for again. It's not necessarily you were the best at submitting an idea. It's just, again, your idea is probably creatively and technically the most feasible thing we can do. Okay, so that's, and also you submitted it early. So if you submitted it late, then I probably didn't get to get to choose that idea. Okay, first idea is Ida's one, and that is visualizing anger. So I broke it down in terms of what you probably need to think about. Again, you can expand on it all you want, but I need to see I guess aspects of that, right? So there's going to be an aspect of anger, right? Oozing out from the head. So you probably need some sort of head. You can download it or you can use stuff inside Houdini. Okay, but again, that's the first idea. We're visualizing anger. So we start off with, let's say, it can be an actual head or it can be a abstraction of a head or a creative abstraction of a head, as long as it looks like a head and it's basically uh, representing a head or a person, right? Then we want to see anger oozing out or emitting from the head. So how does anger emit, or how does it ooze out? Does it ooze out like liquid? Is it something like fire? Is it something like smoke? Or is it something like, I don't know, swirls? That is something I'm going to leave it up. I'm going to leave to you, right? But the idea behind it is cracks start to appear from the head. In fact, it's you probably want to see some of that anger oozing out of the cracks, if that makes sense. Okay. Then another thing I need, if you are choosing this idea, another thing I need to see is the head slowly shattering. Okay, now the fast shatter, slow shatter, where uh, we can actually see it shattering to shards, right? Perhaps similar to something like this, or again, how it looks like. I'm going to leave it up to you, but we should see the shatter, and the shatter should start peeling off, I guess, uh, the humanity of the person. Okay, and then the last thing is with the shards shattering, so we see it shattering, the anger within, so we can actually see what an angry head, quote unquote, looks like. Okay, it's almost similar to your butterfly, but I want you to visualize that. I want you to see, what that might look like. Okay, or investigate or experiment how that might look like. Okay, so is this clear in terms of what this particular idea does or what this particular idea means? Again, you can expand on it, but the basic stuff that I want to see includes those three elements there. You can expand that, add particles or whatever. You can create some really cool abstractions, but the important thing I want to see is these things. Okay, is this clear for everyone? Just checking. If it's clear, can I quickly check who among you is interested? Again, you want to choose as soon as possible, right? You don't want to choose at the end of the. You don't want to choose at the last week. It won't work. Okay, so you really have to choose as soon as you can. Okay, anyone interested with visualizing or choosing this idea? at this stage. You don't have to decide, but what I will do though is I'm going to share it in Teams. Okay, so maybe in Teams, what I'll do. Whoa, let me just do it here. So what I'll do, everyone, is okay. So we have, you know what? Let me just, I guess, share this. So let's see. So idea one, anger. Oops. So anger, who will do this? I'll paste it there. And if you can kindly just reply, that'll be great. Again, I just want to see if we're doing, if, who's doing that. So we have Andrew potentially doing it. So question, again, the idea behind this is, see, you have to visualize that what that anger within looks like. So again, that is a creative challenge, right? So the correct question is, how can I visualize the inner anger and perhaps abstractify the human or the head out of that? So that's the correct question to ask, rather than is assigning a red color enough to do that. So basically, we just need to rephrase the question, I guess. So think of it as a designer, really. Okay. So question from Ida, yes. You can choose ideas that you don't own. Okay, so you can choose any of the four. So we have Andrew potentially doing it. Again, if you are planning to do it, just put it here. So see, just reply on this particular post. I just want to see if you're doing that. So if you're watching the recording, can I ask everyone? Can I ask you, or can I ask the people watching the recording, later on to just reply on the correct idea that you want to choose for the last assessment? Okay. Okay, so that's idea one. So we potentially have Andrew there. Second idea. Okay, the second idea is from Douglas, and that is, again, second idea is from Douglas, and the thing that you're visualizing for this idea is greed. Again, you can choose this idea, or you can choose the three others that I'm going to, present. But the idea behind this is you start off with an apple and a branch. And Douglas mentioned that this is AI generated. So let's visualize that then. Okay. So can you start with something else? Yes, you can, right? So if you don't want to start with an apple and a branch, I guess you can, but maybe the apple and the branch has some correlation between them. But again, you can potentially choose others if you want. Okay, but you start off with two objects. Okay, then what happens is the coins start packing or start surrounding both objects. Okay, so that's the apple and the branch. And then once it's fully packed, meaning it's surrounded by those coins, it will gradually fall. Okay, meaning one after the other. Again, when I say gradually fall, that's a visualization challenge. How do you make it gradually fall? How can I make that, interesting? How can I make that elegant? Okay, so again, if I say fall, you can just have all of them falling all at the same time, and technically you delivered the brief, but that's not, again, the idea behind it, right? Can I make that falling of points elegant, and can I make it look appealing? Okay, so that's your role as a designer, right? And then again, last thing is, again, you can expand on this. You can enhance it with textures, you can enhance it with any type of, abstraction if you want, but I really just want to see those elements there, right? As the basic. That's your starting point, at least. Okay. Make sure you have those coins gradually fall. you can have as many cuts as you want. And then the last thing is the more coins that fall, the more the object, the original object disintegrates. Okay, so what does that disintegration look like? Will it be similar to what you did with the butterfly, or is that going to disintegrate like smoke, or will it disintegrate like sand? Again, these are things you just need to think about yourself, right? I won't. This is a visualization challenge. Okay. So, anyone among you? So, anyone here potentially choosing that idea? So, just checking. Again, what I'll do though is I'll just share it in Teams, and let's see if you guys reply on that particular, I guess, challenge. Okay, so what I'll do is start a post, and then this is forgot. Was it greed? Greed, and then who chooses this? And then I'll just paste it there. Okay, and then just reply if that's what you want. Again, the reason why I'm asking is I'll just cover if you need help. I'll just cover techniques needed for that particular. So if there's not a lot of students choosing one idea, then I'll probably just skip that idea and have you choose something else. So the sooner you can reply, the better, right? So we can just, I guess, streamline things as well. Okay, so let me just. Okay, there you go. Okay, so just reply there if that's the idea you want. Next idea, everyone is going to be this one. Okay, so this one, shadowy scene. Okay, so this is from Kalen, I think. Depression, and that's a shadowy scene with shifting animated boxes. So if you are choosing this one, we need the scene to be really deep. What do I mean by deep? See, guys, notice that that's not just five or not. That's just not 20 boxes. That's probably 100. So see, notice that there's a really nice deep focus there. And notice that the scale of the character is small compared to the environment. So these are, you can probably see around 100 boxes there. So you probably want to animate them procedurally and find ways to create that. Okay, so if you are choosing this particular idea, okay, we need the scene to have shifting and animated boxes. Okay, that means some of them can be static, but majority of them, a huge majority, should be shifting, should be moving. Okay, now they're going to be moving in different ways. Okay, so maybe the ones that are flying might be moving up and down. Okay, maybe some of them here are moving left and right, or maybe left and then right. Okay, and then maybe some of them are moving in, maybe the one on the walls, for example, maybe they're moving in different ways as well. So again, you're basically, you want those objects to shift and move, similar, I guess, to something like this. Okay, so refer to the image. So if you are choosing this, that means there's going to be a lot of cubes there, and if you are animating them, you have to probably think about how to animate them, procedurally. Okay, notice that there's a depth of field there. Okay, so it's a huge scene. Okay, notice that that's probably some sort of fog. So take note that that's a foggy environment with some random bright fires. This doesn't even have to be fire, really. That can just be, you know, lights if you want. But a lot of ways you can go about, or it can be points that are emissive. So again, that can be a lot of different things, right? Um, and again, with random bright fires, with the points with those lights moving as well. Okay, and then you have shifting shadows and dark areas on the ground. Okay, so what do you mean by shifting? It might be either the light moving, or it can be something that you do with materials or colors. Okay, so maybe some sort of noise you can play around with with regards to shading and perhaps with regards to color. Okay, so who among you guys are interested with this idea? Maybe I'll just share that as well. Okay, so Tracy is interested with that one. Again, choosing depression. Okay, okay, there you go. Right, and then post. Okay, so Huang as well, choosing that. That's great. And lastly, okay, last from Jason, ADHD. So it's basically it's it's a lot of colors, a lot of I guess colorful elements, but they're now competing against each other. So a lot of great stuff happening, but they're actually now competing against each other. Okay, so if you are choosing this particular environment, okay, we start with a simple environment and then various different objects slowly appear. So maybe one after the other. And then as they appear, they have their own unique animation, right? So for example, if spirals appear, you might want to animate them as spirals. If let's say lines appear, they behave in a specific way. If let's say it's spheres, then maybe they behave in a particular way. Or maybe it's cubes. So cubes behave. So these are animated elements. So each are animated elements behaving in a certain manner. Okay. Then what happens is they start. So this is the tricky bit. How can you make them look like they're competing against each other? Okay, so it's still, I guess, it looks nice, but they're actually competing against each other. So again, the idea behind ADHD is, again, you do have a lot of those elements competing against one another, and then it becomes, something like a messy situation, right? So, and then what that means is the movements will affect each other. Okay. Yes, so there's a lot of ways. Maybe this one you'll probably end up using. You might need to learn something like Vellum or soft body simulations, and I'm going to cover that today. So a lot of this. So the good thing is all those four, you'll benefit from knowing how to use Vellum, and that's probably our last main topic. After we cover that, then it's really just you guys experimenting with a lot of this stuff. Okay, so we might just cover soft body simulations today, and then we'll have a look at perhaps other things, moving forwards. Okay, so anyone interested with this? And I'll share this as well. Okay, so I'll start a post. This is ADHD. So ADHD visualization, and then post. Okay, just reply. And again, the reason why I'm doing this is so I can just see where the class is with regards to, what concepts you're visualizing. So we can just streamline topics based off those, I guess, ideas. Okay. So you want to choose as soon as possible, really. Okay. And that's it. Okay. So I like that idea as well. From Wang. Okay. And again, you do have some examples. Okay. So as soon as you can decide, everyone, the better. As soon as you can, really, as I mentioned. So, question from Ida: when do you need to decide? Definitely not week 12. So, as the soon as possible, right? So, the sooner you can decide, the better. So you can start, or you can concentrate your efforts on experimentation and stuff like that. Okay. So, is it clear what everyone needs to do for this assessment? Just checking. Any questions before we continue? No questions? Again, visualizing just one. So no questions. That's good. Okay, great. So what I want to cover today, that's right. So question from one, yes, you choose one of those four. And again, with regards to one of those four, I specified what you need, what I at least need to see. So this is your baseline. This is the minimum stuff that I need to see, right? You can expand on it if you want. But as I mentioned, if you're visualizing anger, I need to see the anger oozing out of the head as cracks appear. So maybe parts of the head. So when you say anger oozing out, that is a visualization challenge. How does it look like? Is it water? Is it liquid? Is it fire? Is it smoke, etc.? I'm going to leave, is it particles? Leave it up to you. The head slowly shatters. So again, how do you do that shattering effect? Okay, next is the shards, shattering, anger revealed inside. So how do you see, or how can you visualize, I guess, anger, inner anger, I guess. Okay, because that's what we're, it's almost similar to the butterfly, but you really want to expand that. Really, think about what anger looks like. Similar to this one as well. So see, each one will have specific stuff that I need to see. So if you are doing that, you are doing points, and then this one as well. See, this, if you're doing this, it's a lot of objects. So you can't just do a few. See, notice that that's a really big scene. And lastly, this one as well, that's a relatively big scene, a lot of objects competing with one another. Okay. So, is that clear for everyone? Any questions at this stage? Clear? Great. Okay. So, with that said, there is maybe something. So, a lot of the stuff that you need are was has probably been covered in the first and second assessment. So, the past 8 weeks. There's probably a few, or maybe one that can really benefit you, and that is vellum simulations. Okay. So, basically, soft body simulations. Now, soft body, it's actually applicable to hard body simulations as well, or rigid body simulations. But what do I mean by that? Okay. Soft body simulations, what I normally mean, guys, is anything that moves in a soft, dynamic way. So think about cloth, think about things like balloons, things that actually deform, but also interact with physics and the environment around them. So you have things like collision, you have things like, I don't know, hair, for example, interacts with the environment. That's a soft body simulation. Uh, Technically, you can also consider rigid body simulations as well. So, for example, if something explodes and breaks into pieces, it behaves, as like a physical object interacting with things like the ground, things like the environment around it. So again, you have physical elements or physical aspects or aspects of physics interacting with those individual objects, right? So this is what I normally mean by soft body simulations. Now, we already talked about simulations in the first, week 5 to week 8, I think. Okay. So I already mentioned that regardless of the type of simulation, whether it's particle, fluids, or pyro, it usually has four main components, right? The first component is sourcing. You have to specify what objects are going to be converted into a particular type of simulation, be that particles or something else. So sourcing is important. Then you control the movement. So how can I control the movement of this? Can I use forces? Can I use colliders? Stuff like that. Then controlling the look. So meaning, how do I change colors, add materials, all of that stuff. Okay. And lastly, caching, which is important because when you're done with the simulation, you can all cache it out, and then that's stored in the machine, and that means that you're going to save a lot of time processing it because you already pre-processed the result. So those are our four elements. Okay. So let's have a look at Vellum this time, or soft body simulations. As I mentioned, let's have a look at controlling or sourcing first. Okay, so let me just change this. Looks like I accidentally changed things. There you go. Okay, so let's have a look at sourcing first. Okay, so I'm going to open Houdini, and let me just close a few things here. So as I mentioned, let me just create a simple, I don't know, maybe a simple sphere. Okay, so a really simple way of creating your soft body simulations, right? So I'm going to create a simple sphere, okay? And in that simple sphere, perhaps, you know what? I'm going to specify, you know what? I'll just use a simple sphere. I'll just change the properties of that sphere, make that, for example, polygons. And again, the reason why I'm doing that is it just gives me, I like to stay away from the poles. So if you, for example, if you have polygons there, notice that you have a pole there. So see that pole on top. So I just want to stay away from that. So I just stick that to primitives and then maybe increase the number of the frequency there. So I get something like that. So it doesn't have poles, so you usually get better deformation out of that. Okay. Important thing with regards to soft body simulations is it's going to work on meters primarily. Okay. So what do I mean by meters, everyone? Okay. It's working on a particular scale. In fact, Houdini works with meters. Okay. So just to show you guys, if I turn on the grid, okay, basically every single square there is 1 meter by 1 meter. Okay, so yeah, no, actually there. See? So those big squares there, so that's 1 meter. So basically our sphere is 1 meter in diameter, right? So if you it's 1 meter in diameter, it's basically if it's a soft body, it's basically a big balloon because it's 1 meter by 1 meter. So it's actually quite huge. So by default, you're simulating a really big balloon, right? 1 meter in diameter. Okay, which is fine for now. Okay, but just take note of that. So again, a piece of cloth that's like a few centimeters wide or just has a few centimeters in area simulates totally differently than maybe a very big cloth that's as big as, let's say, a flag, for example. So that one is totally different from, let's say, something that's very small. Okay, so you have to think about that when you're trying to create these types of simulation inside Houdini. Okay, so again, shattering a building that's like uh, I don't know, 200 meters tall is totally different from shattering or destroying a house that's really small, or maybe it's just a toy house. So, again, those two simulations are totally different. So, think about that when you're creating any type of simulation. Okay, so anyway, sourcing. Okay? Relatively straightforward, everyone. Okay? Sourcing is basically telling Houdini what objects you want to use as a soft body. So this sphere is definitely something I want to convert into a soft body. And how do you do that? You just tell Houdini that this you want to initialize this object as some sort of soft body. So to do this, in Houdini, I'm currently in geometry. What I'm going to be looking for is Vellum. Okay, so there you go. Vellum is basically the soft body simulator inside Houdini. Um, so if you have a look at this one, guys, as I mentioned, you have to config figure. You have to tell Houdini you want to convert this object into a piece of cloth. So how this works, you just tell Houdini, you know what, configure this object into cloth. Okay, or configure this as a balloon. Okay, so what I'll do is maybe I'll configure that as cloth for now, and then I'll plug that in. Okay, notice that it requires three inputs. Okay, the first input is the geometry you're actually converting into cloth. Okay, the second input is the constraint. Okay, now this is actually a constraint. What you're doing is a call development constraint. So notice that by default, you can choose not to put anything here because basically the moment you put it in, it's also going to add the appropriate constraints there. And lastly, there's also collision geometry if you need it colliding with something. Okay, so notice what happens, everyone. We're just, again, the moment I add that in, what we're able to do is we're able to tell Houdini, convert that object into cloth, and then we're going to specify, how this cloth behaves. So things like stretching, things like bending, and things like other things here. Okay, so this is basically your sourcing stage. Okay, so I'll just select both of them. Okay, so I'll just, again, this is very basic, right? Just the basic method. So I'll just add a network box. Basically, this is your sourcing. Okay, nothing happens yet. You're just telling Houdini you configure this object as cloth. And notice now that it does it like that. Okay, so we've done that. Next thing, everyone. Okay, so we've done the first thing, right? As I mentioned, we have sourcing. You just want to control the movement. So how do you control the movement? This is where you plug in a solver, similar to what we did with particles. Remember, the solver calculates the movement and the interaction of that particle simulation. So solver is going to be vellum, and just look for solver, vellum solver, right? Now the thing with the vellum solver though is just take note, it requires a few inputs as well. Number one, it requires the geometry. So it's this one, right? Second, requires the constraint geometry, which is this one. Okay? So basically how this works is the geometry is the one you're deforming, and the constraint geometry is basically giving you the properties or the mechanism in terms of how this object behaves. Okay? And lastly, it does require your collision geometry. We don't really have a collision geometry, but I still end up connecting that. Okay? Now, in the vellum solver itself, notice that there's a few things there. There's a start frame, similar to what you normally have. There's substeps. Now, normally with substeps, you want to calculate in between frames. So I normally just increase this to 2 or 3. So I just want to increase that. So basically what substeps does is if your objects are moving too fast and there's something happening in between frames, substeps allows it to calculate that. Okay, so I'll just add that in. Okay, so with that said, I just want to just focus in one other thing. Notice that you actually have ground position there. Okay, so let me just turn on ground position. Basically, that gives you a ground. We can use a collider, but for now, I'll just turn on that ground position. And you know what? I'll just move the sphere higher. So I'll just move the sphere higher using the manipulator and maybe just move it. Okay. So guys, notice now that I do have that solver, relatively straightforward stuff. It does the calculation for me. Okay. So what this means is this is basically your movement, right? So I'll just create a new network box. Jeez. And then it's this one. So again, this is sourcing. It's like I didn't see color. Whoa. Do that again. Okay, so as I mentioned, guys, this is movement. Okay, there you go. Right, so what I'll do now is, let's see if it actually works. There's the sphere, and then there's our movement. Okay, so if I hit play, everyone, notice what happens. I'll turn on this real-time toggle, hit play, and notice now that it does calculate. Now, it does eat up a lot of resources, but there you go. Okay, so notice what happens. It does give you that particular, um, so there you go. OpenCL. Let's see. Maybe it's your simulation solver. Try restarting. Also, it might depend on because usually with this one it uses OpenCL, so it might require your graphics card. Uh, but most graphics cards have OpenCL anyway. Especially, but if you're not using, let me just check, I guess, because you might be able to change it to a different OpenCL. There you go. So you might turn off OpenCL, I guess there, or in the solver itself, you might want to perhaps, let me just check that one out. But anyway, by default, you normally get something like that. Okay? Okay, but we're still not done, guys. Okay? Because as I mentioned, third thing is we're controlling the look. Okay? So, to control the look, couple of things you can do. First up is I want you to have a look at the vellum, a special vellum node, and that enhances the look. And that's vellum post process. So vellum post process, okay? And again, it requires 3 inputs. So basically the geometry, the constraint, geometry, and the collision. Okay, and then there you go. Okay, so notice what happens now. If I just look at this, if I hit play, I get that. But notice, guys, that this post vellum effect has some really interesting uh, parameters for you. It can create a blur and it just softens out So the blur basically it just softens out the the position or the movement of the individual points in your vellum. So that means if it blurs it out, it'll just remove a lot of those spikes, and those spikes create the spikiness you sometimes see. So for example, if I didn't zero out, see, notice that you have spikes, see, somewhere there. So blurring that out, so it's going to refer to the values beside it and then just creates a better looking simulation. So blurring it out. On top of that, you can also subdivide this, meaning after it's simulated, notice that, see, you still have that number of polygons. You can actually increase the number of polygons. And see, notice now that once you subdivide, you just get a smoother image, a smoother mesh. And lastly, you can even extrude that if you want. And then extruding basically just gives it a little bit of depth. Okay. And again, on top of that, you can add your attribute adjust color, right? Now you don't have to do it here. The truth is you don't necessarily need to do it here. You can actually do that uh, before it's being simulated. But for now, see, I'll just put that here and then add that as my network box. And then this is basically our look. Okay. So see guys, notice now that I have that. Okay. Last thing, everyone, is we just need to think about caching. Remember, we cache it out so we don't have to calculate it every single frame. Okay, so what happens is we can just use a file cache. Okay, remember, caching is really important. Again, a lot of you cache after the material is assigned. I normally assign the material after you cache it. So again, I prefer that you cache it first, then assign the material. Okay. So, question from Ida: can you have it inflate and deflate? Yes, you can. So, a bit more advanced, but we'll just cover the basics for now. Okay. So, yes, you can. Technically, you can have it inflate, you can have it tear, all of that stuff. Okay. But we'll just do it in a simple manner first before we have a look at, because it's a topic to itself, really. So, here, guys, what I'll do is I'm going to specify where I'm saving this. So, as I mentioned, specify where we're saving it. It in my oops, I didn't actually specify a project, so make sure to set a project. Set project. I think I'll just students, documents, PGW, my sim, accept. Okay, and then let's just specify where I'm saving this. So ABC, new folder, and I'll just call this balloon. Not it's not even a balloon. Um, you know what? I'll just put a name there, accept, and then give it a name. Balloon. Okay, and then from 140 to 1, and then what I'll do is I'm going to just save to disk. Okay. So what happens is it's going to store it to disk. So as I mentioned, everything's going to be cached, so you don't have to calculate it every time. In fact, what I like doing, if I'm happy with the cache, I can just disconnect it. So let's just have it clear up. Okay, so there you go, guys. Okay, so basically this is caching, right? So as I mentioned, you don't even need that connected. Once it's cached, you just have that running. See? And now I have something like that. Okay, so see, now I have something. Okay, going back. Okay, let's just, as I mentioned, this is your caching stage. Okay, so there you go. So is the process relatively clear? Okay, so just yeah, I mean it is a plus. I mean the thing is you can explore that in level 300 if you want. Uh, but again, with bachelor's degree, the idea is you try out different um, CG processes, just to allow you to see, different types of processes, right? And then maybe in your last year, you can explore specific ones that are really interesting for you. Okay. So yes, you can explore that more in level 300, although there's really no specific subjects for that. Okay, but just checking if this is clear for everyone with regards to the simple process of sourcing it, movement, and then we have look, which is the vellum post process, and then caching it out. Okay. Any questions before we continue? Relatively straightforward. Okay. So if this is clear, everyone, okay, let's just take it a step further. Okay. So what do I mean by that? Okay. So with regards to sourcing, lots of things you can do. Okay. Just to prove my point. Okay. So what I can do, for example, okay, so maybe I'll close this. Okay. Let me just create another sphere. And maybe with this other sphere, I'll just place that all the way to the top. Okay. So there you go. Okay. So there is a special effect inside Houdini, right? That allows you to break up your objects into different shards or different, I guess, fractures. And the way to do that, a lot of ways to actually do this. One simple way of doing that, everyone, is notice that you have under models. Again, notice that you also have something there called shader. Okay. So what that means is I can potentially, right, just click on shader. Okay. So you know what? I'll just click on shader. I won't select anything. Click on shader, and then I'll just select this object, which is our sphere, the second sphere that I created. Press enter, and notice what happens. It creates a shattering effect for you, just to prove my point. See, this one, if I go in, notice now that it has a couple of nodes there. Okay, so how does this work? You start off with a sphere, okay? And this sphere, you create what we call an ISO. This is actually a convert to VDB. It's basically a VDB fog. So see, if I activate that, it's basically converting that into a VDB. And the reason why it's converting that into a fog, because you can scatter points around the fog. So see, notice now that instead of just scattering on the surface, if you have a fog or a VDB, it's scattering it in all three dimensions, basically the entire volume. So notice now that it's the scattering points around it. And there's a special node called the Voronoi fracture, which creates fractured shards based off the points you generated here. So a bit more technical, but basically what it does, it creates that particular effect. Now, if you increase the number of shards here, total count, basically the number of points, notice that you're actually increasing the number of shards there. Okay, so see, it's breaking it up into multiple pieces. Why is this important? This is important because you can actually convert that into vellum as well. Okay? So, what do I mean by that? So, see, this is our starting point. Okay? So, with that starting point, everyone, what I can do is I can potentially convert that into vellum. Remember, we just convert it to vellum. Okay? So, instead of you can configure that as balloons, cloth, etc. But I'm going to do something different. I'm going to configure that um, as a rigid body. Okay, a body that does not deform too much. Okay, so to convert it to our body that doesn't deform too much, I'm going to use a special vellum node, not configure. I'll just use vellum constraint. Now, why constraints? Basically, guys, these are all constraints. This configure balloon, these are actually all constraints. Okay, if you just want an empty constraint that doesn't specify whether it's a balloon or not, just use this one, the vellum constraint. Okay, plug that in. If you don't believe me, have a look. See, the constraint type, you can actually change that to balloon. You can change that to, well, pressure. Balloon is pressure, but you can change it to hair. You can change it to cloth. You can change it to others as well. But the idea behind it is I want that to be rigid. So the constraint I want to use is the last one, which is shape match. And this allows you to treat it as rigid objects instead of soft body objects. Okay, so what I'll do is I'll connect number one, this one. Okay, the truth is you only really just need that, okay, as your connection. Although you can choose to also connect that because this is your constrained geometry output. You can also connect it there. Okay, But again, guys, we're just converting that to shape match. Okay. Now, notice that it has stretchiness. Okay, actually, the stretchiness here doesn't really work. The reason is if it's rigid body, it doesn't really. If it's a rigid object, it doesn't stretch and it doesn't bend. And we'll talk about that more later on. But anyway, we've already done that process. Meaning, guys, this is my process of sourcing. We already told Houdini that this is going to be our um, soft body, right? Next thing, control the movement. So I'm going to add a special, again, vellum. Remember, to control the movement, we need a solver, right? And then plug that in, and then I'll just add that in. Okay, there you go. Now what I'll do is I'll actually add my own collider. So remember, we specified a ground collider, but let me just add my own. Okay, so I'm going to perhaps create, I don't know, a grid. Okay, so again, guys, I'll do a grid, for example, and then I'll just plug it in here, for example. Okay, so I'll plug in the grid. You know what? I'll actually plug it here in the constraints. Okay, and then that one is connected there. Okay, so basically what I'm doing, guys, is I'm using that as my collider. Okay, and as I mentioned, under forces, under the solver, I usually prefer increasing the substep. So any calculations in between frames, you're able to add that in. So maybe 2 or 3. Okay, and then everything else looks good. So what I'll do is perhaps just hit play and let's see what happens. Okay, I'll just plug that in. Maybe, you know what? Maybe I'll just remove that. So quick sec. There you go, geez. So just disconnect, sorry, the constraint geometry there. Just leave it blank because it's actually creating the constraints for you first. Okay, so notice now that if I hit play, I get something like that. Okay, so notice now that, again, because we created that fracture, notice that it's now created all those individual fractured elements there. Okay, now if I just change the settings, okay, if I just change the settings of my sphere, okay, so if I just change the settings of my sphere, so maybe, sorry, my Voronoi fracture, notice that by default, okay, so notice that for your Voronoi fracture, the default is it creates an interior surface, meaning it's basically three-dimensional. But what if you just want the, what if you don't want it to be a chunk? What if you just want it to be a surface? Or maybe like an eggshell, or maybe a shell? What you can do is you can just turn that off. Okay? So notice what happens if you turn off the interior surface. Basically, it's going to be almost like shells now. Okay, so what I'll do is I'll make sure that our vellum solver is active. And again, the vellum solver is our movement, right? So I'll just, again, see if that works. Hit play, and notice now that it does work, right? So notice now, see, everything there is a shell. So see, notice now that I have that shell. Okay, so what we're doing is we're adding that in. Um, Now, the reason why it's falling, so let me just explain why everything is falling. The reason why it's falling, everyone, is because in your vellum solver, notice that under forces, there's actually gravity there. Okay? So, if you don't have gravity, if it's 0, notice that it won't move. And the reason why it won't move is there's no force to move it. Okay? So, notice that it doesn't move at all. Okay? And the only reason why it's falling and it's colliding with my grid, so again, I specified my grid to be a collider here. The only thing that is why it's moving is we have a value there, and then -8, for example. And then if I hit play, I get something. So there you go. So is this making sense so far in terms of what we're trying to do? Okay. So notice, guys, that I have that moving, right? Now, what if you actually want to control it more? Okay. But before that, let me just explain why the next thing is also important. Remember, we have a vellum post process, right? I'll plug it in. Remember, the post process allows you to enhance the look of the vellum. So remember, spatial blurring, just remove some of those peaks when it's moving. But there's also detangle, but this is useful for hair. It doesn't really do anything for this one. But notice, guys, this is interesting. The extrude one, though. If I click on it, notice that it actually extrudes. See? It provides an extrusion for each of those elements there. So I can modify the extrusion scale. So it's basically giving those shells some depth. Okay? And notice what happens now. I have something like that. Okay? So there we go. Okay, so what if you want to control this further? Okay, so what do I mean by controlling this further? What if I don't actually want to use, let's say, the gravity here? So I'll zero it out. Okay, and what happens is if you zero it out, if you hit play, notice now that it doesn't do anything. So really obvious, right? Okay, what if I actually want to control it using forces that I create? So what I can do, guys, is I can go inside the Vellum solver itself. So the Vellum solver, if you go inside it by double clicking on it, you can add your own forces. So what do I mean by that? Double click. Okay. Notice what happens, guys. See, you have two there. Okay. You have source and you have force. Okay. I'll activate the force. Okay. I'll activate the force because I'm going to add a force on myself. Okay, so maybe the force that Houdini understands is going to be pop forces. Okay, so pop or particle forces that we covered in the second assessment. So remember, guys, again, I'm inside the Vellum solver, right? It's actually a .NET. See, it's actually a .NET. Okay, so what I'll do is in the force here, I'm again making sure that the output is turned on, meaning this orange thing flag. What I can do is I can add a pop wind. Okay, so there you go. Pop wind, right? So with that pop wind, I can assign things like amplitude and maybe swirl size, and I can just connect that directly there. Okay, so if I hit play, no, if you hit play, nothing happens here. You really have to go out, and then you have to go back to your Vellum solver. And let's see if that actually works. I hit play, notice what happens. I get something like that. Okay. So again, the idea behind this is those are individual. So basically, the moment you used a Voronoi fracture in them, okay, what happens is you're able to. Um, so it's now it's treating those individual shards as separate objects, and now you can have them interact. Okay, so notice now that see I have play and I get something. Okay. Okay, so again, you can add your own. Um, okay, you can add your own pop wind, but we can even take it a step further. What if you want a bit more control? What if I want to specify the area where this wind happens? Okay, so what I can do, everyone, is remember have a look at the pop wind. It actually has a group. Okay, so we can specify a group there. So how does this work? Inside the Vellum solver, what we can do, everyone, is we can add a group, a pop group. Okay, there you go, pop group, right? So with that pop group, notice that yes, you can specify the particles, but more interestingly, you can actually specify a bounding box, right? So if you enable that, notice what happens. Basically that's your bounding box. So anything inside that bounding box is going to be affected by the force. Anything outside the bounding box is not going to be affected by the force. So just to prove my point, if I reposition this bounding box somewhere here, I'll just go to frame 1. Okay? Somewhere there. Okay? And maybe I'll just increase this. So basically changing the size. So, okay. And then again, connecting that. I'll give it a name, guys. Okay. The name of this pop group is going to be Affect Me. Okay. So affect me, and then it's going to be a bounding box, and then in the pop win itself, I can perhaps change it to group, and then use the group affect me. Okay. So what I'll do next is if I hit play, again, you can't play it here because you're currently inside uh, your vellum solver. So I have to be outside, and then I'll hit play. Notice that you get exactly the same results, right? So again, the reason why you get the same result is because all of your objects are inside the, the group. But what if you animate that? Okay, what if I actually animate this this one? Okay, so what I'll do, guys, is I'll go back to my pop group. Remember, this is actually animatable, size and center. So what I'll do is maybe reposition this here, frame one. I'll set a keyframe. Okay, so set a keyframe for this by pressing Alt and left mouse button click, Alt left mouse button click. I'll go to, let's say, frame 120 and then slowly just move it. So again, it's trying to calculate if there is actually a technique where you can disable the simulation. Okay, so but just be careful. You can actually disable the simulation so you can animate stuff. Okay, so for example, this one you can disable that, so you can just animate this, I guess, better easily. So see, guys, I'll just animate that, and then that's frame 120, and I'll keyframe that. Okay, so basically what's happening is, see, you just have that animation. Okay, so what I'll do next is, I think that's good. Okay, so what I'll do is, let's see what the result is. I'll just activate my simulation back, and then let's see what it looks like in my vellum solver. So if I hit play, everyone, notice what happens. See, it will slowly or gradually change. So there you go. So see, notice that again, the reason why this is happening, right, is if you guys remember. So see, it starts here, and then you get that. Okay. Yeah. So notice now that it actually creates that effect. Okay. So again, you can add a post, so vellum post process there, and then you basically have that effect. Okay. If you want it to fall, then just perhaps, again, just be careful, right? If you go in, you have to make sure that, see, your only concern is, see, this will continue to move because it's basically outside. Once it starts moving, it continues to move. Okay, so just be careful with that. So maybe just to show you guys, okay, maybe instead of having it go around the air, what I'll do is maybe I'll zero that out and maybe just have -8 in my y direction, and then so basically it's going to push it down, and let's see what that's going to do. Okay, so if I hit play, I have, so if I hit play, I get something. Okay, so see, notice now the ones here, because they started moving already, they're just now moving everywhere. And the reason for that is, see, you just need to make this bigger. So the pop group, just make that bigger. So maybe here, I just want that bigger. Okay, keyframe that. And maybe at frame 120, I'll keyframe. As I mentioned, guys, it will calculate, so it's a bit annoying. So turn that off. Again, I'm in one frame 120, so I'll just deactivate that. Okay, So I'll just deactivate that and maybe move it down. Okay, and then keyframe that again. Okay, so let's see what that looks like. If I hit play, I get something like this. Okay, so again, some of them are still moving, and then again, the reason for sorry, I did actually activate my simulation. So see, guys, notice now that that should just be careful when you're deactivating the simulation. You have to make sure that you're activating it. Okay, so there you go. Okay, so what if you actually want it interacting with other objects on top of that? Okay, so for example, on top of the grid, maybe you want another object somewhere here. So maybe let's introduce, I don't know, a cube, and maybe for that cube, I'll make that lower. We position that here. So basically, I just have a box. But the thing is, guys, I can just merge those two things together. Remember, you can just do a merge. So merging them, plug in there, and then let's just see what it looks like solved. So similar stuff. Again, deactivated it. So I just need to activate that again, and let's just have it happen. Notice now that it does interact with our box, and then it creates, that type of effect. Okay. Again, make sure you have that post process, and then on top of that, so post process. The problem is it might look weird here, so just be careful. Uh, but you can always cache it, then add the post process after. But we can deal with that later on. Okay. Okay. So with that said, let's have a look at another application for that. Okay. So you have fracturing, right? Let's have a look at another application. Okay. So what I'll do is I'll close that. Maybe do another one. Okay. So maybe again another sphere because spheres are easy, I guess. So sphere. Okay. And again, have it go up. And this time, what I'll do, guys, is I'll just want to use polygon. Okay. And maybe increase the frequency. Okay. So, okay. So as I mentioned, it will work in a lot of different ways. So again, when we talk about sourcing, right? It also respects copy to points. So what do I mean by that? So for example, I have, let's say, a cylinder or a tube. And that tube, I'll just add some caps there. So basically, I just have radius scale, height lower down. So maybe it's something like that. Okay. Okay. So this is our sphere. Whoa. There we go. Maybe I'll make the sphere a bit bigger. There we go. Okay. So I'm going to add some normals to that sphere. And the reason for that is I just want to have a direction for each of those points. So I'm going to add a normal node. And basically, a normal node just assigns a direction, particularly to the points. So basically, that's what the normal does. It just provides a direction for those points. And then what I'll do next is perhaps do a copy to points. So copy to points, similar stuff. There you go, right? So I have, I guess, something like that. You can merge it with the original if you want, but you don't even have to. Okay, I'll just have it like this. If you want to rotate it differently, then maybe just change the rotation here. So meaning here, or maybe here. Okay, but let's say I'm happy with that. In fact, You can even do this differently, everyone. So what you can do is you can use a remesh node, and the remesh node just creates an even distribution of triangles. Okay, so basically, you know what? They actually look the same. But anyway, remesh node, see, and then you have a normals, and then you copy points. So you guess you have something like that. In fact, we can even remesh this to something smaller. Let's say 0.15. So there you go. Okay. So notice now that you just have, again, similar stuff. Okay. What do I mean by that? You can again convert that to vellum, right? So vellum constraints, plug that in, and then remember we're changing that to shape match, right? So to treat it like a soft body. Okay, and then once you've done that, you can add a vellum solver. Okay, vellum solver, plug that in. Okay, you can add forces if you want, but you know what? Let me just add my own grid. So again, I just have my own collider. Plug that in. Okay. And then let's see what that looks like. Okay, I might move the grid lower down. Okay, and let's see what that looks like. Okay, so if I hit play, I get something like, okay, so there you go, right? But you guys already know that you can just easily manipulate this, right? Meaning, what you can do is perhaps, again, under your vellum solver, right? Maybe we'll just zero out again our force, and then maybe in our vellum solver, we just again add another node. Not sure. Let's just use the same thing. So let's just use a wind, a pop wind. Okay, plug that in, and then again go back in, see how that works. Like that, and then on top of that, maybe I'll just go inside. You know what? I'll just have it fall down. It's easier. So I'll just go 8, 0 this one out, 0 that out, -8 because I want that falling down. And then again, similar stuff. Group, pop group, connect, and then lastly, everyone, bounding, enable, and then again, making sure that I modify this. Okay, okay, there you go. Okay, so again, animating this, going up. So again, for some reason, it's that's right. And you can even make the branch a collider, so it also collides on your on your objects, right? So I'll just turn off that one, animate this going up. Okay, and then keyframe that, and then go back to frame one, and then let's see what that looks like. Um, so Vellum solver, hit play. Okay, so I think I still have. Okay, in our Vellum solver, sorry, pop wind, we specify group. The name of the group is me, and then the pop wind is going to be using me, and then that should do it. Hit play, and I get it. Let me just go in. It's just taking time to create. So what I'll do, everyone, is I'll just go here and delete that. So there you go. Okay, one more time. Now, there's actually more advanced ways to do this. So if I'm doing this, I'll probably attach it to objects. So attach it to certain points and then have that interact. But this is an easy way of doing things. We might, if we have time, we'll cover more advanced ways of doing that. But see, the problem with this is you might have limited options with regards to how it's going to, start falling. But I guess we can have a look at some of those techniques uh, later on. Yeah, this is actually hard. So, question from Ida, that's actually hard. So, see, they're not deforming, right? So, there is rigid body simulations, but I won't cover it. Okay, so I actually won't cover it, but this is technically hard. Yes, so lots of applications. So this is where you guys start experimenting and seeing how that works. Okay. Um, Lots of other application. Let me just explore first. You can even use. So maybe one more, guys. With regards to Vellum. Okay. So with regards to Vellum, maybe just one more. So create new. Okay. So this is where exploration will come in, right? So just to show you guys. So I guess I'll provide some tips because some of you are also planning to explore. But you know what? Let me just go over this very quickly. Okay. 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 I guess just to show you guys. Okay. So for example, I have a sphere there, right? And that sphere is emitting, let's say, particles. Okay. So what I can do is it doesn't even have to emit particles. I'm just showing you that if it is emitting particles, so you can also convert that to vellum. That's what I mean. Okay, so basically, guys, okay, remember how we can create particles from spheres? We just add a particle a pop network. Okay, so from that pop network, we can just have it, I guess. So I'll have it spread out particles. And I guess one way to do that is I'll scatter it on objects, but I'll also go to attributes and I'll just add to inherited attributes and give it some variance and let's see what it looks like. You know what? I'll actually do it differently. What I'll do is I'm going to add a normal node and I'm going to convert the normal into. So the idea is remember the normal, it's pointing outwards from your object. So it's going to look something like that. Okay. And I just make this points. In fact, if you have a look at the geometry spreadsheet, see, those normals is basically a vector. It's just pointing out towards, I guess, away from the point. But the thing is, you can convert that normal into velocity. So that direction, you can convert that into velocity, meaning it has its own speed and its own direction. Okay, so the way to do that is a lot of ways. You can use a wrangle or code, but this one I prefer not to use code when teaching. So for example, this one I'll just use a um, VOP, so attribute VOP. Okay, so I'm looking for attribute VOP, and the idea behind this is inside the attribute VOP basically you can connect attributes together. So as I mentioned, I can connect or convert the normal vector to the velocity vector. Okay, so notice now that, see, I now have initial velocities on each of my points there. Okay, so the reason why this is important is because your pop network actually, so your pop network, so let me just turn off this one. So this is important, guys, because your pop network actually inherits attributes, right? Including the velocity. So what I can do is I can just use inherited velocity. When I hit play, I get something like that. Okay. So it's just pushing it out. Okay. So what I'll do is maybe I'll just change the number of points being emitted to something smaller. Let's say 100. Okay. And then I just have it like that. Okay. And I can even make that uh, I can just lower down the inherent velocity so it doesn't move too much. So it's going to move, I guess, something like that. Okay, the reason why I'm covering this is because, right, if you have something like this and you want to perhaps have a lot of different objects, okay, the thing is you can use copy to points, right? But you can actually use multiple objects for copy to points. So what do I mean by that? Okay, so what I mean is just to show you, I have a cube, okay? And then on top of that cube, I'll just lower that down scale wise. So maybe I'll have a sphere. Okay. And then with that sphere, I'll lower that down. I can even have, I don't know, pig head. Okay. Lower that down. Okay. I can maybe one last, I'll add a torus. Okay. And then scale it down. Okay, so you guys already know how the copy to points work, right? So if you use the torus, then you have something like that. Okay, but if, for example, you use the pig head, then you have something like that. Okay, but what if you want to use multiple objects? It can be as many as you want. Okay, so what you can do is lots of ways you can do this. I'll just show you something that doesn't involve coding. So again, something that doesn't coding, what I'll do is maybe all of this. So four objects there. I'll first merge them together. Okay. So merge them, right? One, two, three, and four. Okay. Disregard that because one of them has materials. So next thing is we're going to add a special node called connectivity. And basically what that does, it just assigns, creates a new attribute. I'll show you what it does in your geometry spreadsheet. See, it just creates a new attribute. Okay. So basically what that means is if it belongs to the box, it assigns it a unique number, let's say 0. If the points are in the pig head, it assigns it a unique class or number 1. If all those points belong in the sphere, it assigns it a unique class attribute. So the attribute name is class. Okay? Okay, so why is that important? Because here, okay, before we connect it, what we can do is we can create an attribute from pieces there. Okay, so what this means is this creates an ad. So this allows us to create. Let's see. So what I'm doing, right, is I'm connecting the attribute from pieces. Okay, so what this means is going to use the connectivity, the class attribute here to generate unique points onto your copy to point. So I'll just show you what I mean. Okay, so notice now that, see, notice that you have geometry library. I'll connect that to my connectivity. So let's see, there you go. So it's going to plug in, remember, the class attribute directly here. Okay, now the name of our attribute is called class. So I'll actually change that, class. Okay, and what I'll do is I'll also connect this connectivity to this one. Okay. Now have a look at the copy to points, guys. Okay. Notice that it has something there called piece. Okay. So I'm going to use the piece attribute, but remember we actually named it class. So I'll just change this to class. Okay. And notice what happens now. Okay. If I activate that, See, some of them are using the pig head, some of them are using the spheres, some of them are using the cylinder or the torus. So it's basically random. It's not really random. If you want it totally random, notice that you can actually change it from your attribute from pieces. Notice that the mode is set to cycle. I can change that to, let's say, random, and now it's totally random. Okay, so see, so some of them are using the sphere, some of them are using the pieces. Okay, now notice that I'm basically just getting that. Okay, now, again, those are particles, guys. Okay, so I won't even expand on what you can do with particles because we've been doing that for such a long time already. Okay, maybe later on I'll show you that you can actually connect particles to fluids, but for now, I'll let you expand on that yourself. Okay, but see, that's a particle simulation, and then from the copy to points, you can do that. But on top of that, what you can do, all I'm saying, right? On top of that, what you're able to do is you're able to connect that to vellum, right? So if you want that, if you want those objects interacting with one another on top of that, then you can use something like a vellum node. Okay, um, but it's just a bit tricky though. Let's just set it up. So vellum, I'll use a vellum because we don't want that to be a hard, rigid body. So a really nice soft body is the vellum. I think struts. So let me check. I think it's struts. Not struts. Let me just vellum. Let's try vellum balloon. Configure balloon. No. Maybe let's just use cloth. So I'm just going to treat it as cloth. Okay, so cloth. And I'll probably end up sharing. I'll share this file to everyone in a sec. Cloth. Okay. So vellum configure cloth. Plug that in. This the problem with this is it has a concept that's a bit tricky because the thing with vellum is or simulations is it's only going to calculate what's happened on the first frame. Okay, so it doesn't really consider what's happening on other frames. It's going to initialize everything in the first frame, and that's going to be an issue, I guess. uh Stress. So you know what, basically let's just have it like that. All I'm saying is we can play around with it, but you can convert that into vellum. You know what? Let me just do that, I guess. So vellum, um, balloon, plug that in, and then you have that as a vellum. Um, Configure vellum sim. So similar stuff that we did. So solver, plug that in. Okay, activate that. As I mentioned, see, so you added it in, but notice that it doesn't really work. Okay, and the reason why it doesn't work is see, if I hit play, nothing's happening, even if I play, because again, it reinitializes itself. It's only considering what's happening in the first frame. So notice now that, see, nothing's there. And there's also duplicated point IDs, but let's see what we can do. Uh, let's see if this works. If it doesn't work, then we'll just choose something else. Let's see. Copy the points. So again, I'm just testing something, guys, before we have a look at one last thing. I'm just checking if this works for this one. If it's not going to work, then it's fine. So copy. It looks like it's not. So we'll just have a look at this later on, I guess. You know what? It's actually working now. Let's see. So we just need to delete that error that we had. And basically, I can do that by just adding an attribute delete. But I guess we'll just cover that later on. Okay. So again, notice now that I can do it that way, right? Where you have it like that. And then on top of that, you can even have them interacting. Okay, I think that's it for now. Okay, maybe one more. Okay, maybe this one. This one is probably relative. I mean, everything we covered in the first week, in the first 4 weeks. So it's quite similar, right? So I guess I'll just show you guys. Okay, so this is multi objects. This is geez, I forgot simple vellum. This is Voronoi, and then this is. I mean, I'm sharing it, but it's really, it's really just the tip of the iceberg. But it's fine. You can just explore it. And this is copy to points. Okay, maybe one last thing. Okay. Uh, let's see. Just hide everything. I mean, that one is probably the easiest because you really just need to explore. So, for example, guys, right? You know how to use scatter. Okay. Right. So you basically you have something like that. Okay. And you know how to use copy to points. Okay. And basically you have something like a cube. Okay. So maybe I'll just make that smaller. And again, I won't even deal with things like p scale, scale, and all that stuff, right? But the idea behind this, right, is if you just explore, okay? So it's easy to maybe set it up, but how can you start shifting it? And this is where you just need to analyze, what node allows you to move points. So in the copy points, what node allows you to move points? Remember, you have something like attribute adjust float or attribute adjust color. So maybe I'll use attribute adjust vector and let's see if that works. So attribute adjust vector. Okay. So maybe let's see if that works. Okay. And remember, it uses velocity. It's not velocity we want to change, right? It's position. So let's go position. Okay. And notice now that we have maybe some sort of noise there. Okay. And maybe we'll have that animated on top of that. Okay. So what happens is we have something like this. Okay. And then let's just remove, I guess, the fractal, right? So it's smoother. Again, this is where you end up playing around with it. Okay. And maybe lowering down, I don't know, posturation. Okay, so see, notice now that the problem is it's been moving in all directions, right? But the thing is, guys, if you just spend some time exploring it, notice that, see, it actually has a component scope. Meaning, if you don't want it moving, and let's say you just want it moving in the x-axis, notice now that it just moves in the x-axis, right? If you don't want it moving, you only want it moving in the y-axis, notice that it does move in the y-axis, right? And if you don't want it, or just want it moving in the z-axis, and then notice that it's moving in just the z-axis. Okay. Now the question is, the challenge here is how do you make it look cohesive though? And that's the challenge for that. Okay. So the reason why this is cohesive, guys, is its design. Meaning, see, notice that the line, the perspective lines there is clear, meaning you don't have a lot of extrusions here. It's your eyes are clearly leading you towards that horizon point. See? So notice that most of the stuff that's moving is going to be on the sides rather than direct. So see, it's a design element there. It's how you place objects and how you move objects. So if I'm doing it, I think about, you know what, if the objects are farther from the background or really far away, I'll have it move slowly. Maybe the objects nearer can move faster and stuff like that. So this is where you need to start thinking about design, thinking about how things might work. Okay, you might even consider, if they're shifting and moving, can I have them collide? Can I have them, for example, those two objects there, can I have them collide and then maybe shift, move, and then move again? Okay, so how do you do that? This is where, maybe vellum might work, maybe something else might be feasible. This is where experimentation comes in. Okay, so with regards to experimentation, this is your week 10 challenge, right? Depending on, again, there's going to be specific problems there that you guys need to solve or you guys need to explore. Okay, now the thing is, if you have the same concept, I will allow you to share solutions or ideas. So for example, you'll end up sharing the same type of problem, right? How can I move an object up and down in an elegant way? Okay? So you can just share solutions, okay? But the important thing is you have to really explore. You have to find ways to make that look elegant. So what I'll do is I'm going to issue that here. Okay? Okay, so I want you to break it down, right? It's going to be obvious what you need to break down anyway. So what I'll do is I'll go to Teams. And in Teams, I'll go here. Okay? And I'll just start a post. And I'll make this an announcement. Okay? So so this is where we start finding ways to implement our concepts. So this is week 10 challenge. Okay? So and this is due next week. And again, as I mentioned, right, you can share ideas. That's why I prefer breaking it down, and we'll talk about that in a sec. Due um, 26. Let's have it due on Thursday, May 1. Okay, and then I'll just post this. So that will make this a bit more organized. What I'll do is let's assign it. Okay, let's assign something that you can explore and maybe share your solutions with other people. Okay, so what I'll do is PGW200, and there you go. Okay, okay, so let's start off with. So, as I mentioned, guys, okay, just find one possible solution for some of the challenging features you have in your specific concept. Okay, so an example for this. Okay, so for the students who are interested doing anger, okay, see more. Okay, so anger, for example, one question, challenges. Okay, uh, how can you have what oozes out of the cracks? So how can I make, so let's say, how can make anger. Okay, so see, that's challenge number one. Okay, challenge number two. So challenge number two, everyone, um how can I shatter the head elegantly? Okay, so how can I do that? Number three, uh angry looking head. Okay, so abstraction. How do you create an abstraction? Okay, for this challenge, okay, based off the students who are interested here, who's interested just for this week, just for week 10? due next week. Who wants to test out how to emit anger from cracks? Anyone here, particularly Julia and Ida, who among you might want to explore? Again, as I mentioned, the reason why you want to do this separately is you can share ideas after. So, for example, if Ida is doing, let's say, the shattering of the head elegantly, then maybe Julia can do the anger emitting from cracks, and then you can share notes afterwards. Okay? So, anyone else planning to do this one? So if you can if anyone is interested with this, so Andrew as well is interested doing this, is it? Okay, so if you don't, I'll just assign. Okay? So let's see. Let's see if Andrew can find a way. Okay? So week 10. Let's see if Andrew can find a way to have anger emit from cracks. Okay? Let's see if Julia. Let's see if Julia can find a way to shatter the head elegantly. Okay? And let's see if Ida can find a way to create an abstraction of the head that looks cool. Okay? Great. Now, if you're watching the recording, then just engage as much as you can. But see, guys, what this allows you to do is it allows you to focus in a specific problem, find a possible solution, or a nice abstraction of that, and then just share ideas and solutions afterwards. Okay, so that means it can be stills, it can be screen recordings, and then just explain your idea. You can even share your Houdini file. Okay, so let's have a look at another one. Tracy, Rosie, and Misarg. Okay, planning to do depression. Okay, so some common themes here, right? Let's see. And Wang. Okay, great. So, questions here, guys. How can you create that deep looking environment? Okay, deep, vast, vast looking. So you don't again, you don't necessarily want to think about the movement. You just want to think about how you can create that vast scene without actually modeling it, right? If you end up modeling it, that'll take you forever. So how can I do it procedurally? So procedurally creating a vast, deep, a deep, vast looking. When I say deep, vast, notice the scale, right? See, it's huge, guys. Okay, it's really huge. You have nice depth of field, and then you have nice environment fog as well. So, how can we create that vast looking environment? Okay, anyone interested with this? Okay, so Tracy wants to. Again, we can have more than one person doing it. Okay, so Tracy, we can. So not quite sure what the question is, Ida. Yes, I mean you can that can be a shader thing. Yeah, I mean that can be a shader thing. That can be an entire head made of fire or smoke. I guess similar to a Balrog. I don't know. I mean going to leave it up to you, right? You don't have to model the head. Okay? So or that can be uh abstraction, head, anger, fire, I don't know, smoke. It doesn't even have to be fire and smoke. That's really cliche sometimes, right? So I actually like that as well. Or, or maybe I don't know. I leave it up to you. Okay. Or maybe it can be something like something like that. That's almost uh burnt. I don't know. I leave it up to you, right? Okay. Shattered glass, totally fine as well. Okay. So shattered glass as well. Okay, so as I mentioned, doesn't matter. Uh, you can just you can just reply there. Okay, Sophia is interested as well. So Tracy wants to have a look at procedurally creating that vest. Anyone else who wants to do that as well? So wants to, again, don't worry about the movement. Concentrate on how you can perhaps create the look. Okay, how can you make that? So it's going to be a combination of your camera, depth of field, perhaps using environment fog or some sort of VDB, just to create that really deep look. Okay. Okay, so one is interested with the head with the smoke. So that's good. Let me just check that here. So one, and then elegantly Julia and Ida. Uh, okay, so Ida, you're talking about this one, the the sorry, the number two. Okay, so you can I can put your name there as well. Okay. So now I'm totally confused, which is which. Jeez. So I'll just post this for now. Tracy and Ida. Um, so uh, shifting blocks or architectural elements. Anyone interested in exploring that? So again, it's easy to make it move. How can you make it move elegantly? Is what you want to do. So Tracy, Wang as well. Okay. Architectural elements. Anyone interested? Again, what I'll do, everyone, is I'll just put it in, and you can just reply. Okay. And then we also need someone to perhaps. You know what? Maybe this one. How can you create procedural fire points, or procedural lights, random lights and fires in a big environment. Don't even need to do a simulation for that. I'm thinking you can just use an object that's emissive, but make sure to perhaps have a look at how you can make that animate. Okay. So again, just reply there. So I won't put your name in. Just reply there. If you are using, let's say, anger is good. This one, if you're doing this, then maybe think about emitting, having multiple appear in empty space elegantly. Okay. Adding unique animations on unique objects. So as I mentioned, guys, if you have unique objects there, how would they move? If you have a spiral, for example, how will that spiral move? If you have a sphere, how do you want the sphere to move if you are doing this particular concept? And then perhaps you can also how multiple objects pack and interact. Okay. Yep. So just reply if you want to have a look at some of them. Yeah, just reply. I haven't. So glow from brightness. You can try it out. You'll know if it's enough, if it looks good. So the best way to do that is to just try it out, see if it works. If I'm basing it off the image that you guys provided. So see, You know what? I can even imagine those are just simple single points or small spheres that are emissive, meaning they're assigned emissive material, so they're actually emitting light. And then if you have an environment there, it will interact with the fog and it creates that effect. So again, that's where your experimentation will come in. Not quite sure what you mean, Sophia, but yes, just reply on those, I guess, or you can, if it's confusing because we didn't really organize stuff here. If it's confusing, just, I guess, message, and then so see, just message and then just let us know. This one as well. Obvious things that you need to think here. How can you perhaps um, disintegration cool, disintegration effect? Okay. And then how perhaps potentially how can you pack points nicely? Okay. And then you can even take it a step further. Uh, or see, so a lot of other things, right? So maybe and it can be simple as rendering a nice apple and uh, branch. So creating a nice photorealistic rendering out of that might be an option as well. So there you go. Okay. So I think that's it, everyone. Any other questions? Some questions I'm not clear in terms of what you mean. You can just type it in. But yeah, so if I didn't specify your name there, just, I guess, reply. Let me know what challenge you want to do. Again, the great thing about this is if you're able to, you can share notes, right? So yes, technically, you can, if all of you work on the same challenge or uh, you know, the same feature, then there's going to be other features that have no solutions at all. So I do prefer that maybe find something that someone hasn't isn't doing yet, because that will help you, right? That will help, I guess, each one of you, come up with different types of solutions. Okay, so hopefully that helps. Okay, so is that clear, everyone? Any questions before we go? This is all recorded anyway. So we covered a few things. Now, what I'll do is let's see what you come up with, and then let's see what challenges you face, and depending on your challenges, I'll just cover techniques that will help you with those challenges. So again, a lot will depend on what you're trying to achieve, right? So let's see what happens. Okay. So looking forward to seeing what you come up with. Okay, and then I think that's it. Okay, so I'll see you guys next week. Any questions, feel free to send me a message as well, or you can just type it in. But do make sure you have an idea that you're keen, because we don't have a lot of time. We have this week, next week. You don't really want to do a lot of work in the final week. That's like all of your, assessments due. So do as much as you can now. Okay, and that's it. Okay, and I'll see you guys then. Okay, so have fun. Okay, see you guys then. Okay, all good. See you then. See you guys then.